Hey guys, so this assignment is going to be covering one of the most missed subjects that I saw across the board, and that was the dependent and independent variable. So, what I'm going to give you the opportunity to do is work on an exit ticket, and if you get those questions right, it'll replace that grade for the dependent and independent variable. Now, I'm creating this video because I want to actually walk through with you one time what it is and work on an example problem before I set you off to do that. So pay attention to the video, take down any notes that you may need, pay attention to the example, and then when you go into that makeup assignment, you'll be able to get everything correct and boost your grade up. Now, let's begin. The independent and dependent variable. In any experiment, there is always a dependent and independent variable. Dependent variables are what is being measured. It's the outcome in the experiment. Independent variables are what you, quotation marks, you change in the experiment. This affects the results, the dependent variable in the experiment. So dependent variables are going to be the outcome they're looking for. It's the thing that we're measuring. The independent variables are the things that get manipulated. They're the things that are being changed in the experiment in order to see what happens to the results. And we'll see what I mean by that in the example in a second. The last thing is constants. Constants are every other variable that is kept the same in the experiment. You keep them the same so that they do not affect the result of the experiment. Remember, you should only ever have two variables in an experiment, a dependent variable and an independent variable. A dependent variable and an independent variable. Everything else should remain a constant because you do not want it to affect the results of the experiment. So let's check it out. We're going to go to this one example, and then I'm going to allow you guys to go out and try this on your own. So, a scientist wants to see if the pollution a factory is adding to a lake is affecting the health of the fish in the lake. When the scientists took samples of the water, they determined that the amount of pollution in the water got smaller the further it was from the pipe that was adding it to the water. All right. The scientists made a hypothesis that the closer the fish were to the pollution, the less healthy they would be. The scientists took 5 samples of water with different amounts of pollutions in it. He made sure to keep the amount of water, the type of fish, and what the fish ate the same. He then measured the health of the fish over the course of a month to see if there was a change in it. So our questions are, what's the dependent variable, what's the independent variable, and what's the constant? So let's figure out the dependent variable first. It's the outcome that we're trying to measure. It is the outcome that we're trying to measure in this experiment. And so if we actually go back, let's read the first line. A scientist wants to see if the pollution a factory is adding to a lake is affecting the health of the fish in the lake. So the purpose of this experiment, the reason we're doing it is to see how the health changes. Our dependent variable is going to be the health of the fish. The health of the fish, because that's the thing that we're measuring to see if it changes. We're measuring the health of the fish throughout the experiment. That is our dependent variable. Now, our independent variable is the thing that's going to change, that we, as in you and I, we are going to manipulate in this experiment. So the scientist took samples of the water. He determined that the amount of pollution in the water got smaller the further it was from the pipe that was adding it to the water. The scientist made a hypothesis that the closer the fish were to pollution, the less healthy they'd be. He took 5 samples of water with different amounts of pollution in it. We just found our independent variable. The thing that we're able to change is the amount of pollution in the water that we're getting. We took 5 samples, and that's the only thing that's changing in this experiment. The amount of pollution in every single sample is going to be different. So that's our independent variable. Our independent variable. Our dependent variable, one more time, is the health of the fish. Our independent variable is the amount of pollution in the waters, because that's going to change in every one of the experiments. And what we're trying to see is, does the amount of pollution affect the health of the fish? So there should be a causal relationship there. There should be a relationship between the two of them. Then the last one. What is the constant in the experiment? So constants are going to be everything that we're trying to keep the same so they do not affect the results of the experiment. So we have our dependent variable, which is the health of the fish. Our independent variable is going to be the pollution, because that's the thing that we're changing every time we do the experiment to see if it affects the health of the fish. Some of the things that we kept the same are right here. He made sure to keep the amount of water, the type of fish, and what the fish ate the same. Those are our constants. But why did he keep those constants? Well, he wants to make sure that it's the same amount of water, so that way one fish doesn't get a smaller amount or a bigger amount, because that could change the amount of pollution in that amount of water. So you want to keep the water levels the same so that doesn't affect it. You don't want to have a fish with less water, because maybe that'll hurt its health. You don't want to give it more water because that might hurt itself. So you want to give them the same amount of water for all the fishes. You want to use the same type of fish because maybe some fish are affected more by pollution than others. You don't know that, but you don't want that to be a factor. So you keep the same type of fish and you make sure that the fish ate the same exact thing. That way, that does not affect their health. If they all were eating the same thing and in the same amount, you know that that's not going to be a factor in there. They're going to be exactly the same. So they should not play a role in there. And so with those three things, we just found our dependent variable, our independent variable, and our constants. And I need you guys to remember, whenever you're doing these, always ask yourself for the dependent variable, what am I measuring? What's the outcome that I'm trying to see at the end of the experiment? Whenever you do your independent variable, always look for the thing that's going to change that outcome. This is the thing that we're manipulating in the experiment because it could potentially change the outcome. Once you find those two, the dependent and the independent variable, make sure that everything else stays a constant because you don't want your results to be messed up. You want to make sure that as many things as possible can remain constant. And whenever you get a problem like this, you should see in the problem that they're going to tell you what things are going to remain constant. They will tell you what things are going to remain constant. They'll tell you what you're measuring for, what you're looking for, the thing that you're going to be manipulating. And then remember, everything else is going to be a constant because you don't want it to mess up your results. So anyway, guys, that was it for this quick video. You guys can go ahead and give it a try on the credit recovery. And other than that, do the best you can. I'll be grading these later, and I'll see you guys later. Bye.